Okay, so if you skipped the last video because you know hashing functions, the only thing you missed relevant to Git is that Git uses a specific hashing function called SHA-1. Although this is set to change eventually, it still uses SHA-1. It generates 40-digit hexadecimal numbers, exactly what we've been seeing. This is the output of the SHA-1 algorithm. This is as well. And these are commit hashes, right? 40-digit commit hashes. But Git actually uses SHA-1 in many, many other places, not just to generate commit hashes. If you recall, let me find the slide. I mentioned that there are 4 types of Git objects, 4 types that Git can store, including commits, but then there's also trees and blobs and annotated tags, all 4 of which are hashed using SHA-1. So we're going to get to all 4 of those data types or object types throughout the course of this section, but I want to start by just explaining something about Git. Git is a key value data store, meaning that we can put data into Git, right? We ask Git to store something for us. That could be a file, it could be a folder, or it could be 100 files and folders. We could even just tell Git to store a piece of text for us, which we really don't do because all the times we make text in a file. But I'm about to show you, we can just give Git a piece of text and have it store that as well. So we can put all sorts of content into a Git repo, and Git is going to hand us back a unique key that we can then later use to retrieve that content. Like when you go to if you ever go to a bar or a club or a concert venue, and there's a coat check, right? They take your coat, they give you a unique key that corresponds to your coat, and then later on you go back and say, hey, here's my key, give me back my coat, please. So the keys that we get back in Git are SHA-1 checksums, or the output of the SHA-1 hashing function. So here's a demo. Imagine we have a file called app.js, and I'm using Git to track the changes, right? I've made one version of it and then a second version of it. And for each version, I've used Git to store that file and its contents. Now that's actually somewhat complicated to understand because it does store files and contents separately, but we'll get there. Anyway, each one actually gets its own unique key. So you can see the keys here. Okay, so they are the output of SHA-1, just like a commit hash, and they each correspond to some value, some piece of data. So if I have one of those keys and I tell Git, please give me the content for this key, it's able to use that and figure out, oh, I know what I stored under that. It's v2 of app.js. Here you go. So we've seen a basic version of this using commit hashes, right? Where we say things like, check out this commit hash. I want to view the contents of this commit, and we give Git that commit, and then it can go look up corresponding information. But what we haven't seen is that Git uses these hashes all over the place. It's fundamental to how Git works, but so much of it is hidden behind the scenes. So in the next few videos, we're going to walk through this. We're going to see these different data types and the role that the SHA-1 hashing function plays, not just to make commit hashes, but also for trees and blobs, and then also annotated tags, but they're kind of an afterthought for us. So let me summarize that, hopefully quickly. Git allows us to store any sort of data in it, and it will hand us back a key for that data. And that key will be a SHA-1 hash that we can then use at a later date to retrieve the information we stored. So a key value data store. We store stuff in there, and it gives us a key. We can then come back and give it the key to get that value. So we'll see that in the next video.